Or get one before the wind.
Yeah, I had no idea I was gonna get this windy, but I'm glad I got it done yesterday.
Oh, thank you. We still need to pick up the exam.
Yeah, right there.
Perfect, thank you. Oh my God, a lot of people still didn't pick up their exam. All right, you take that path. Luke, Kevin. What's this? No, I'm not in touch. Oh, bottom. You didn't bottom, you saw it?
Sure, trying to do the homework we had yesterday.
Yeah.
How far are we like?
Whoa.
Are we
able to communicate to about?
Yeah, yeah. I mean, we're having one more example with taxes, and so maybe it might be helpful to see this last example, just because it's a bit complicated. But you should have everything that you need to do.
Yeah. Mind put it on the board?
Yeah, sure.
On the home one, it was like. The number line where all the options, right?
Yeah.
So what I did is whatever this is like A. E. Over A.
Yeah.
Or whatever A is, you can put some sum, right? I, right?
Mhm.
But then I also did the over. Is that correct or no?
Yeah, that works.
Awesome.
Yeah, because what this does is it takes the A, converts to a P, right?
this
A is in the denominator, P is up top. And then, if you want to move this, you know, it depends where this starts, right? So if it starts here, doing A, P over A, maybe you put it right here. What this will do is that we put it, move it back here, sorry. Yeah, because this is taking something that's in the future.
Now, this is getting to my issue is it was asking for the rate of revenue.
Yeah.
Right? So I did it, and I was looking at the answers right there, so I just tried to do it around the answer.
Yeah,
So I did it at 5%, right? And it gave me a negative number, right?
okay,
And then I did it at 8%, and it's like 7, the answer's like 7 or something,
yeah.
and it gave me even more negative.
Yeah, there might be an issue with how you set up this equation, because the crossover should be, right at 7, between 7 and 8%.
Yeah, because it was like extremely, it was like negative 40,000 here, and this
Yeah.
was like negative 80.
I see, okay. Well, there might be an issue with how it's set up. If you want to email me your work, I could take a look.
All right, thank you.
Yeah,
Oh, those are.
that's fine.
Oh,
I don't use it, so
That's right, I know.
the next professor can do it. But, oh, all right.
I don't like leaving
My bad. You, it's me.
something for somebody else.
It's fair.
All right, thank you though.
Yep.
Future son. Yep, we're done. This was- Easy one.
It's looking at the middle grade. Who's gonna say it's like tiny, and it was like fog.
Oh, ew, God, that's gonna get all that pollen. No. Yeah, it sucks. It's funny because it's only the spring that hits me hard than the other time. Yeah. Did you ever post, did you ever post Tuesday's lecture on YouTube?
Oh, I haven't yet.
Okay.
Yeah, I'm a little behind, so I'll do that today.
No, you're fine. I was dying Tuesday.
Oh.
So I was like, I didn't even go and I was like, I don't remember we posted it.
Yeah, I'll post it after this.
Thank you. Yeah, you sent me that equation. I did get that from. Like the example, I can't think when I was like, I don't remember seeing this here, but it wasn't there, right? And I looked at his example, that's like pretty cool. I looked at his example and I was like, no, I didn't know the way it looks, so I'm not reading this. I'm just no. I really used to understand the whole equation. I didn't know, like, I have a pen. And like, I was sitting up and I was like, okay, that hurts. Really, really great skills. No. We had two. I know we had solid mechanics before I had this one on a Tuesday. And Tuesday. I should do this. Oh, you didn't bring your charger. Yeah. Well, you just bring it with you. I use it as a carry case. It's always just in case. Just in case. So I said, here, I was like, oh, I meant to message you back and I was like, why don't we use your keyboard? I thought your keyboard had a slot. Oh, that's right. She gets the fancy one. I don't know what you. Use a. Yeah, I have the older model, which means we can't get the fancy keyboard that has a little slot right here. The newest models have a little slot that goes right here, so you can charge with them. Oh, that's right. I'm sorry. I have that. That's my backup. Yeah, they're tiny. I did the same thing. And I tried looking for the rechargeable versions of it because I have a lot of rechargeable batteries. I tried looking for it. I couldn't find it. That's the thing. It's too small.
If you did, it's expensive because of that.
Yeah. So I usually have I have backups. I have that one as a backup thing. I still so I have I was going up to long or something. So I did drawing. That was enormous. So I stole that piece off and installed it onto that one. Yeah. It's
Final step.
right. Oh my god, because it's 9, 10, yeah, because spring break's on the week of it. We're almost there, but we're almost there. We got this. Hang in. We do that to everyone. Everyone, awkwardly did that. And again. Oh, it's funny. Can I do it? The turkey.
It do
The jellyfish. I clean them. Here.
No.
What's your name? Island. Yeah.
Either parachutes on the front or you jump in.
Oh, yeah, I saw that. I'm glad you noticed. Some people don't notice haircuts.
Oh, yeah. I got dinner with one of my best friends from high school yesterday, and even he didn't notice until I pointed it out to him, so.
No, he is.
My wife didn't even say anything, so I went home and I'm like. She's like, oh yeah, you had a haircut.
I'm so bad at that.
All right, it's 1 o'clock. Let's go and get started. Thanks, guys. All right, so today is Thursday, week 8. So we have another lecture planned for today, so same as usual, so nothing too exciting. We are starting a new topic for today. Well, I should say we have one more tax example to finish up from last time. And then we're gonna start our new section today on replacement decisions. Okay. All right, so a couple announcements. Remember you guys are working on the homework assignment, so make sure to get that in. I'll have the next homework assignment ready for you guys soon. I know homework 4 was a pretty long one compared to the other assignments. Homework 5, which is going to be the last homework before the second midterm, is going to be shorter. So it'll be shorter than the most recent one. Right. So my plan for homework 5 is to do a bit more practice with tax problems, just because I know those it's always good to practice those ones more, and then a bit on replacement decisions. Okay. All right, and so with that, we're actually almost done with our economics section here. So once we kind of finish with replacement decisions, there's a little bit on inflation. I lied. There's one more section after this. But then I think right before spring break, we'll start to work into ethics. And so that's kind of the second portion of this class, right? So we're wrapping up soon. So, we're not going to see economics. We're only going to see economics for a couple more weeks. And then, then we'll move on to the humanities portion of the class, I guess you can say. Okay. One more announcement I want to make is that not related to this class directly, but next Friday there is going to be an event hosted by the department. And so you may have gotten an email this past week about a study hall next Friday. So the idea behind the study hall is that we're just providing a space and snacks and food and coffee for you guys to study. So it's going to be next Friday, March 22nd. It's going to be in the engineering building, EE 201. So come on by 4 o'clock, there will be coffee, I'll be there. And so if you want to ask questions about 401 or just anything, you can come by and hang out for a couple hours, right? I'll send an email with the link to the RSVP, because I think the department wants to know how much food they should order for next week. Okay. All right. Any questions I can answer before we get started for today? Okay. All right. So let's pick up our example from last time. Okay, so I'm just going to scroll up here a little bit. So this is kind of what we started last time. So this is kind of our last example with taxes, and so this is probably the most complex example that we're going to do because it kind of brings together a lot of different concepts, and so I think that's a good way to kind of wrap it up, right? All right, so the setting for this one is that you work for a company and they just purchased a suite of research computers for 150 grand, and these research computers are expected to pull in $50,000 of revenue each year in terms of like the design output, right? There is a yearly maintenance cost. There's a maintenance cost of $10,000 each year. And what we want to do is we want to compute an after-tax EUAW. So that's an after-tax annual cash flow analysis, right? Okay, and so with any tax problem, you need to know a few things. And so we need to know how this purchase is going to be depreciated. So we are going to subject this research computers to a 40% bonus depreciation. The rest of the book value will be depreciated using an MACRS scheme with a 5-year property class. These machines are planned to be used for 5 years, and at the end of the 5 years, they can be salvaged for $25,000. The interest rate for this problem is 8%, and our tax rate is the usual standard 21%. Right. So there's a lot going on here, and so let's kind of take this step by step and solve this problem. Okay, so let's come down here first. Okay, so let's do some kind of pre-calculations first. Okay, because this is the first example problem that we're doing that has both bonus depreciation and another type of depreciation. Okay. So we talked briefly about it last time, but you'll actually see kind of it in action right now. Okay. All right. So our initial cost for our asset in this problem was $150,000, right? And what we said was that 40% of this will be depreciated away immediately using bonus depreciation. Right, so the way bonus depreciation works is that it's you depreciate away a percentage of the initial cost. And so what we're gonna do is we're gonna take our $150,000 here and multiply it by 0.4 in this case. We do our simple math here and we get $60,000. Right? So under bonus depreciation, our research computers have lost 60% of its value right from the get-go. Okay, and that's going to happen during the first year. And so at this point, remember when we're talking about depreciation, we're really only doing it for tax purposes. And so, it's not that, it's not that the IRS determines, how valuable your computers are. That's determined by the market, right? But when we say that we're applying a 40% bonus depreciation, that in terms of tax, in terms of the tax, taxes, we can say that we can depreciate or deduct away 60% or $60,000 of value. Okay. And so this depreciation isn't necessarily a loss in market value, it's a tax deduction. Okay. Okay. And so that means that after the $60,000 is depreciated away, right? We just do simple math here, do 150,000 minus 60,000. We have $90,000 of value left. So after the bonus depreciation, we're going to have the remaining $90,000. And this is what we're going to apply to MACRS. Okay. So we can actually pre-compute this, and that's kind of the beauty of MACRS, is that everything is based off the initial book value. Okay. Because we know going into this problem that we are going to apply a 5-year property to this, or 5-year asset. Okay. And so through that, we know that under MACRS for 5 years, so I'll call this MACRS 5, okay. We know the percentage of the of depreciation that's going to occur in each year from the table. Okay. So this is from the table that we listed last time. All right. So under MACRS 5, we know in the first year we're going to lose 20% or depreciate 20% of value. In the second year, we're going to depreciate 32.00. Third year, we're going to depreciate 19.2. Then in the next year, we're going to do 11.52. Okay. Fifth year, we're going to do 11.52. And remember, whenever you have a using MACRS, there's also a 6th year as well. Okay. Or 1 year after the property class. So we're assuming that we're still using that machine for half a year after that 5th year. Okay. So these percentages are what we're going to multiply by the initial book value to get us our depreciation amounts. Okay. And so you have to be careful here because, the number one mistake I see in these problems that people make when we're combining bonus depreciation with another method is that they take these percentages and multiply it just by the initial cost, right? And so what I see people all the time doing is that, you take your MACRS percentages and you multiply it by, in this case, our initial cost, which is $150,000, right? But we're not going to do that here because we've already depreciated away 60,000. And so what we're going to do instead As we're gonna multiply this by the remaining book value that's there after the bonus depreciation. Which is $90,000, okay? So we're gonna multiply each of these percentages by 90,000. And that's gonna get us our depreciation schedule or depreciation charges for each year. Okay. All right, so let's go ahead and do that. And so we're going to take 20% of 90,000, which is 18,000. Okay. Then we're going to take 32% of 90,000, which is 28,800. Then we're going to take 19.2%. 19.2% of 90,000 is 17,280. Then we're going to take 11.52% of that, which is 10,380, 368. Okay. Then year 5 is going to be the same thing, 10,368. Okay. And then we're going to take 5.76% in the 6th year, which is 5,184. Okay, so this table here lists out our depreciation charges each year. Okay, but in the first year, right? The first year we can't forget our bonus depreciation. So in the first year, our bonus depreciation is $60,000. Okay, so that first year we're going to depreciate away 18,000 plus 60,000, which is 78,000. Okay, and then every year after that, we just follow the MACRS values from there. All right, so that's how you combine bonus depreciation with another method. You first take the bonus depreciation, you get that percentage, right? Then whatever's left, then you apply your other depreciation scheme to just whatever was left after that. Okay. All right, any questions on how we got this table here? Okay. All right, so from here, let's go ahead and make our table. All right, so I'm going to form our table a little bit differently, and this is a little bit more consistent with kind of what you'll see on the homework. Okay. Usually, the first thing that we list in the table is the before tax cash flow, but I'm going to break that up because there's actually a few different before tax cash flows here. Okay. So on the one hand, we have revenue. We also have the maintenance costs. Actually, let me just do those two. Let's just do those two. Right, so both of these here are before tax cash flow. Okay. Next column we have is going to be our depreciation. We've already computed the depreciation. That's just what we did up there. So we're just going to copy that down here in a second. Okay. Our next column is going to be taxable income. I'm going to collapse it a little bit just because we're going to need a little bit more room. Next column after that is once we compute our taxable income is to multiply by the tax rate. And so that gives us our taxes. And then once we do that, once we compute our taxes, we're going to subtract that from our revenue. And we're going to get our after-tax cash flow. Okay. Okay. So there's a lot going on here. So we're going to do kind of each step kind of one by one. Right. All right. All right. So let's start with year zero, actually. So year zero of your tax table should only really include the initial cost. Okay. Because that's the only thing that happens at year zero, right? So I was debating whether I should make a column for the initial cost, but it would just be in year one and year zero. So even though it's not a revenue, we need to put it somewhere. And so I'm just going to put minus 150,000. Okay. I know it's not actually revenue, but we had to put the initial cost in year zero somewhere. Right? Every other column except for the last one's going to be blank. Because at the present time, we didn't pay any maintenance yet. There's no depreciation, no taxes just yet, and so everything's gonna be blank. So with the initial cost, we're just gonna copy over to the end, right? That's kind of what we typically do here. Okay. All right, year one. So from the problem, we know that every single year, the revenue that we're going to generate from these machines is $50,000 per year. Okay. So in year one, we're going to have $50,000 for the revenue there. Okay. We also know from the problem that the regular maintenance on the computers is $10,000, right? So for the maintenance column, we're going to put 10,000. For the depreciation in year one, we're going to have $78,000, and so that's going to be 18,000 plus 60,000. So now we have to compute our taxable income. So remember, to compute our taxable income, we take our revenue for the year, we subtract away any regular and necessary expenditures, and then we subtract away the depreciation. Okay, so that's why I separated it here, because the maintenance cost is considered kind of a regular and standard necessary expenditure. Okay. So that's money that the company has to pay in order to run its business, right? So it has to pay its maintenance costs. Otherwise, the computers are not going to operate, right? And so to compute the taxable income, we're going to actually subtract that 10,000 from our revenue. So first thing we're going to do is we're going to subtract 50,000 minus 10,000. And then from there, we're going to subtract another 78,000 from there. Okay. And so 50,000 minus 10,000, that's 40,000. 40,000 minus 78,000 is a minus $38,000 taxable income. Okay. Right. And so when we have a negative taxable income, that tells us we're going to get a tax credit. Okay. And so our tax credit in this case is going to be 21% multiplied by the 38,000. And there's actually a typo in my notes. I'm going to compute it right now. Okay. And so our tax credit for this year is going to be minus 7,980, okay? Almost $8,000. Okay. And so our after-tax cash flow in this case is going to be our revenue minus our maintenance. And so our maintenance, that's money that we actually paid out. Okay. And so minus our taxes. Okay. So we're going to take 50,000 minus 10,000 minus a negative 7,980. And so that leaves us with 49,000 or 47,000, excuse me. 47,980. All right, so I think this is the first problem that we've done as well with the necessary expenditure kind of baked into the problem. So I know that's kind of something we talked about early on when we started talking about taxes, but you can kind of see factored into the problem here as well. Okay. All right, any questions on how we got the numbers in that row there? Okay. All right, so let's go ahead and keep going. All right, so for the second year, we're gonna have the same revenue, same maintenance costs, so 50,000, 10,000. Our depreciation for this year is 28,800. Okay. That means our taxable income in this year is 11,200. All right, so in year two, we're actually gonna pay taxes. And so you multiply that by the tax rate, we get 2,352. Okay. You subtract all that from each other, we get 37,648. All right, and from here, it's just repetitive, and so you're just going to be doing the same thing over and over again. So in year three, we have 50,000, 10,000. Depreciation in that year is 17,280. So our taxable income in that year is 22,720. We multiply that by 0.21. We're going to pay $4,771.20 in taxes. So that means our after-tax cash flow is 35,228 and 80 cents. All right, so let's just finish this up. And so next row is going to look like this. Notice how we're paying more and more taxes each year because the depreciation is going down each year, right? And so under MACRS, in bonus depreciation, you kind of backload your tax burden. So, you don't pay a lot of taxes early on, but then later on, you want to make sure that you have the funds to pay for these taxes. All right, in the last year. So the last year, we're going to make our $50,000 like usual. But remember, the problem also mentioned that we're going to be salvaging our machines for $25,000 that year. So our total revenue is actually 75,000. So the $50,000 we get from the normal work plus the $25,000 that we're going to get from salvaging it. Okay. We're still going to pay the maintenance, and so our maintenance for that year is $10,000. Okay. Our depreciation in this case, since we're not going up to 6 years, but even though our table goes up to 6 years, we're going to fold this remaining book value into this year. Okay. Okay, so we're going to add these together since we are salvaging in year 5. Okay. All right, so if we add those together, we get 10,368 plus 5,184. Okay. All right, then our taxable income in this year is 49,448. Excuse me. Thank you. All right, so then the taxes we pay. I have another typo in my notes. I'm sorry. Oh my goodness. The wind is making my allergies go crazy. 49448 times 0.21. Okay, so the taxes that we're going to pay is 10,384.8. Okay. That means the after-tax cash flow is going to be 54,000 615.92. Okay. All right. All right, so we're just about done. So the last step here is just to compute the after-tax EUAW. Okay, so we're gonna take all the cash flows here in this table. We take note in terms of which year that they occur in, and we can use our interest rate of 8%. As we can compute our after-tax EUAW. Okay. For the sake of time, just because I want to start working on replacement decisions. I'll go ahead and leave that up to you. And while you guys are still copying that, I'm going to grab a tissue because my nose is going crazy. All right, any questions? Any questions on this example here? Okay. All right, so that's taxes, and so with taxes, I think the problems look really intimidating just because there can be a lot that's going on at any given time, especially when you have necessary expenditures. You have state taxes. I think one of the problems in the homework throws state taxes in there as well. So there can be a lot, and so the key with tax problems is to just be really organized, make sure you account for everything, and make sure you put it all in the table, right? And if it helps, I know it helps me a lot of the times too. Definitely you make use of a spreadsheet program, use tables, use formulas, just to make sure your calculations are consistent, okay? Most of the time, the only thing you have to really compute by hand in these problems is the depreciation schedule, right? Especially if you're using something like MACRS with bonus depreciation, I would at least compute those by hand. And then all the other calculations you would kind of automate in a spreadsheet or in an Excel table, okay? All right. So that's it with taxes. Let's go ahead and move on to our next topic, which is economic life and replacement decisions. Okay. So the whole idea with economic life analysis and replacement decisions it all revolves around this idea of when should you replace one of your assets or business expenses. So we've been using replacements in our problems, especially when we did present worth analysis. There were a lot of times when we had to buy replacements in order to reach the least common multiple and things like that. Okay, and so we kind of just bought those replacements without really thinking. Okay. In particular, we've basically made the assumption that whatever asset that we have, whatever machine that we have, we use it until its end of life. Okay? Right. To put it another way, we basically use an asset for the duration of its useful life. Okay? Okay. We haven't really defined that term. We've kind of just been using it up to this point. But the useful life basically refers to how long you can safely use an asset, okay? For as long as possible. Okay. That's usually what it says on the box, or that's what that's what the dealer basically tells you, that you can use this car for 15 years or whatever. Okay. There's another concept when you're talking about project management or management of engineering projects, which is economic life. Okay. The economic life of an asset is how long an asset should be kept that maximizes its economic value to the company. Okay. And so on first blush, these two seem like the same thing, right? The useful life and the economic life, right? Because it makes sense that if you buy something, you should try to use it for as long as possible. Or maybe that's just me being, raised in an Asian household to, only use things for as long as possible, right? And so if you use things for as long as possible, then that maximizes economic value, right? But when you're dealing with kind of large engineering assets and large engineering machinery, these two often are different. So often, the economic life of an asset is less than its useful life. And so what this basically means is that a lot of times it's economically desirable for a company to salvage a piece of machinery or sell it off and buy a new one while the old piece of equipment is still working fine or working. Okay. Which seems, kind of paradoxical, or maybe it's just paradoxical to me, right? So if it's still working, why don't we still use it? But there are a few factors that kind of lead into this. All right. So the main factor that comes up is increased maintenance costs. And so typically the longer you keep an asset, it's going to be more expensive to maintain it. Okay. And so that could be for a lot of different reasons. So, as an asset gets older, as a piece of equipment gets older, more things tend to break down, and so it costs more to fix it. One thing that's especially relevant in engineering is that if you have a particularly old piece of equipment, replacement parts for it may no longer be manufactured, and so all of a sudden you're on the black market of lost Honda parts from 2005. So that could be an issue as well. But for one reason or another, the longer you keep an asset, the more it's going to cost to maintain it. Okay. Another factor is that technology advances. So a lot of times you'll be using a particular asset or particular machine. Maybe a newer version of that machine comes out, or maybe a new company makes a better version of it. that has increased capabilities. So maybe there's an opportunity cost of, maybe you're keeping this old piece of equipment, maybe it works fine, but if you buy a new one, you can do maybe twice the amount of work in half the time, right? And so there's an opportunity cost that's associated with keeping this equipment, which you need to account for, right? And so that's something to think about when you're running a business. Okay. All right, so that's what this whole unit is about. So this whole unit is kind of determining, or we're gonna develop basically a methodology or a technique for determining, what's the best time to replace a piece of equipment. Granted, it's a maintenance cost and also grant the capabilities of newer equipment. Okay, so we're going to combine all that together. Okay. Any questions on this so far? Okay. So with that said, this unit here is actually kind of split into two parts. And so on the one hand is called economic life calculations. Okay. So that's probably what we're going to spend today about. So economic life calculations basically takes an existing asset and determines how long you should keep it based on all of its costs. Okay. So that's what we're going to focus on first. The other part of this unit is actually the replacement analysis or replacement decision. Okay. So in replacement analysis, that's when we're actually going to bring in the capabilities and the cost of a newer part, newer model. We'll probably do that on Tuesday of next week. Okay. All right, so let's start with economic life analysis. Okay. So economic life analysis is pretty interesting because it's one of those really classical cases where we have two competing factors. And so on the one hand, you want to keep an asset for as long as possible to kind of maximize that initial cost. But there's another factor where, maintenance costs are going to increase. And so that kind of discourages you from doing that. Okay. So for any asset, there are two competing considerations. Okay. One consideration is to basically take the initial cost and spread it out over as many years as possible. Okay. I think this is the usual mindset that people have, is that, you take, whatever you paid for initially for an asset or an object or a product, you want to keep using it as long as possible to kind of make that investment worth it. Okay. So under this consideration, we want to keep our asset for as long as possible. The other competing consideration is that the longer we keep an asset, the more the maintenance is going to cost. And so under this consideration, we want to keep the asset for only a short amount of time to minimize those increases. Okay. One thing to keep in mind with number two is that, the older an asset gets, the higher likelihood that you're going to have kind of a catastrophic breakdown. So the whole thing's just going to go just kaput. Okay. And we'll learn how to factor that into our calculations eventually as well. Okay. So when you have two competing factors like this, right? So on the one hand, you want to do one thing, but for another consideration, you want to do another thing, right? And they're polar opposites of each other. Okay. Whenever you have this in any kind of a situation, that this kind of implies that somewhere in the middle, there's kind of a sweet spot where both of these are kind of satisfied as closely as possible. Okay. So it's not too long, not too short, but just right. Where that's the optimal amount of time to keep an asset. Okay. Okay, so let's see how we actually do this. Okay. So let's do a simple example. So let's say that we have an asset or an engineering machine that had an initial cost of $7,500. Okay. The useful life for this machine is 10 years. So what that means is that it's technically possible to use this machine for 10 years if it's properly maintained. Okay. This machine is going to have a yearly maintenance cost, and so the yearly maintenance cost is going to be $1,200 in the first year. But then each year after that, it's going to increase by $900 per year. Okay, so we have a gradient, we have an arithmetic gradient situation going on. All right, so if we assume an interest rate of 8%, we're going to ignore taxes in this case, just to kind of keep things simple. Okay. compute the economic life of this machine. Okay. All right. So that's our situation, right? So we have a pretty standard case here. So we have a machine, we have its initial cost, we have its yearly maintenance cost. We know the maintenance cost is going to increase per year. And so from there, we could compute what its economic life will be. Okay. All right, so how is this done? Okay. So usually for economic life calculations, we want to do this from an annual cash flow point of view. Excuse me. Thank you. Excuse me. Okay. So I know up to this point, we've used kind of present worth analysis and annual cash flow kind of interchangeably. With replacement analysis and economic life, this really only works with annual cash flow analysis. Okay. So what that means is that we're going to be computing EUAWs. Okay. In particular, this EUAW, we're going to compute it for each year, right? So we're going to make calculations where if we keep the machine for 1 year, 2 year, 3 year, 4 year, okay? Okay. So we're going to be doing this in a tabular format, right? So we're going to make a table out of this. Okay. And so if we do this, what this is going to tell us is that this EUAW is going to represent the yearly cost, the average yearly cost of ownership of this asset for each of those lengths. Okay. Because that's what an annual cash flow analysis does, that it takes your cash flows, converts it to a uniform series, which is a uniform series of payments. Okay. And so what we're going to do from there is that we're going to compare this EUAW for each of the years, and we're going to pick the one where the EUAW is the minimum. Okay. So what that means is that we're going to take each of our cash flows and then convert it to a uniform series. Okay. So let's write an expression for that. Okay. So our EUAW in this case, we're going to take each of our cash flows and convert it to a uniform series, right? So first we have our initial cost, right? So our initial cost is 7,500. Initial cost is always a present sum type of cash flow. And so to convert it to a uniform series, we're going to multiply by A over P. Our interest rate is 8%. Okay. And we're going to evaluate this at different values of N. Okay, so we're going to leave the N there blank for now. All right, then we have the maintenance costs. So our maintenance cost is going to start at $1,200 per year. So that $1,200 is already a uniform series format. And so we don't have to convert that. So we're just going to add the $1,200 plus. we have our $900 increase, and so that is a gradient. So we're going to take 900 multiplied by A over G, 8%, and N. Okay. All right, so what I'm going to do, I'm going to take this expression, make a table out of it. And we're going to evaluate this for different values of N. So let me do this actually. So this first column here, let me make this the years, just so we can read this table from left to right. Okay. And then this last column, let me zoom out a little bit. This last column will be the EUAW, or the sum of all these things together. Okay, so from the problem, we know that it's possible to keep this asset for 10 years. And so I'm going to make 10 rows of this table. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And we're going to evaluate, I'm going to evaluate each of these different cash flows for different values of N. So this first row for year 1, that's if we keep this asset for 1 year. And so we're going to plug in N is equal to 1 here, right? So if we do that, we have A over P, 8% with 1, multiplied by 7,500, that gives us 8,100. Okay. The $1,200 is constant, and so the 1,200 is just going to become 1,200. Okay. And then we have A over G, 8% and N. Because it's a gradient, the gradient has, it hasn't kicked in year 1 yet. And so our gradient in that column is going to be 0. And in fact, if you look up the compound interest table for the A over G column, the first row is 0. Okay. All right, so if we add these up, we're going to have 8,100 plus 1,200. And so the yearly cost of ownership, if we only keep this asset for 1 year, is going to be 9,300. So we basically just, we took our initial cost, we advanced it forward for 1 year. So we actually, that because of interest that actually increased, and we paid the maintenance for that year as well. And so it cost us $9,300 in total with interest, to keep this machine for just 1 year. Okay. All right, so let's look at N is equal to 2. So if we plug in N is equal to 2 into that expression, we have 7,500 multiplied by A over P, 8% and 2. And so that gives us 4,206. Okay. The baseline maintenance cost is still the same, so that's 1,200. And then we have our A over G, 8% 2, which is 433. Okay. Multiplied by 900. All right, so same thing, we're going to add up across the row here, and what we get is 5,838. All right, so you can see that, if we keep it for 2 years, that initial cost gets spread out, among those 2 years. You can kind of say, right? And so our yearly cost of ownership it goes down to 5,838. So pretty significant decline. Okay, so let's do the same thing for N is equal to 3. So for N is equal to 3, our initial cost gets spread out over 3 years. And so that conversion factor, that A over P, 8% 3, multiplied by the 7,500 becomes 2,910. Okay. Our baseline maintenance of 1,200 is still the same. And then our increase here is 900 times A over G, 8% 2, which is 854. And so we again add all these across, and what we get is 4,964. Let's do the same thing for N is equal to 4, so it's just kind of same thing from here. So for the first column, we get 2264. Second column is uniform series, we have 1,200, and then we have 1,264 for the increase in maintenance costs. Okay. So we add up across that row, we get 4,728. So again, we see a decrease, and so you can see that, you know, our investment is, you know, paying off the longer we keep it at this point. Okay. Let's do n is equal to 5. And so n is equal to 5, our initial cost gets spread out even more, so that's 1878. Second column was 1200. Third column was 1661. We add up all of these, we get 4,730 now. Okay. All right. So I'm going to pause here for a second, because what you should see is that, you know, as we go from 1 year to 2 year to 3 year to 4 year, you know, our yearly cost of ownership is going down, right? And in fact, it hits a minimum of 4,728. Okay. As soon as we move past this, as soon as we go into year 5, you can see that yearly cost of ownership has actually gone up. Okay. And so in this situation, you know, so far, you know, the most optimal amount of time to keep this machine is actually 4 years. Okay. Let's do one more row. Okay, so let's do 6 years. And so for 6 years, our first column here is going to be 1622. Second column, we still have the 1200. And then our third column here is 2048. Okay. And so we add all these together, we get 4,870. Okay, so it's gone up again. Okay. All right, so we can continue this, and so, you know, you can definitely fill this in for the rest of the table. But usually once that EUAW kind of hits a minimum, and then once it starts to increase, it's usually not going to come back down unless you have some other stuff going on, right? And so, you know, what we can conclude here is that the economic life of this machine is 4 years. Okay. With an average yearly cost of ownership of 4,728 buckaroonies. So you can see from our analysis here that it's you know, we can keep this machine for 10 years, right? It's going to work for that time, for that amount of time, but it's not going to be economically feasible for that amount. And so it will be better to, you know, after you use it for 4 years, to buy a replacement at that point. Okay. All right. Any questions on that example there? Okay. All right. So that's the basics of the analysis. Okay. So usually, okay, for relatively simple cases like this, the graph of EUAW versus time kind of, it looks like it actually kind of looks like a bathtub. That's what I describe it as. Okay. And so if you plot it, horizontal axis here will be time. Vertical axis is EUAW. Okay. What you're going to see usually is that initially, you know, the initial cost hasn't really had a lot of time to spread out. And so as you kind of go from the beginning, you have this kind of very rapid decline of EUAW. Okay. Then it usually kind of reaches a minimum. And then from there, it kind of slowly kind of grows because of the increasing maintenance costs. Okay. And so it almost kind of looks like a bathtub, right? We have one kind of very sharp, steep edge, and then the other edge kind of grows slowly. Okay? The minimum of this graph, this is the economic life right here. Okay? So again, it's not one that's too short, it's not one that's too long, it's usually somewhere kind of in the middle. Okay. Okay. So I wanted to visualize it for you just so that you can kind of see kind of the logic behind it a little bit as well. All right, let's do a little bit of a more complex example, and I think probably we'll start it and then we'll finish it up on Tuesday. Okay. Let's talk about factoring in things like salvage values and overhaul costs. All right. So the last example that we did was kind of the simplest that you can imagine. So it has kind of initial cost and an increasing maintenance. Okay. What can make things a bit more complicated is when you factor in the fact that, if you sell an asset early, you can salvage it to recoup some of the costs. Okay. The amount that you get from salvaging or from selling, of course, depends on the market price for that good. And if there's one thing that we can pick up from the last unit on depreciation, is that the longer you keep an asset, the market price tends to go down. So that's another kind of consideration that we can, that we need to keep track of. And for the first time, I think for this class, we're going to actually have equations. We're going to have models for, how the market price actually changes with time. Okay. Overhaul costs are another piece of interesting information. And so just to kind of refresh your memory, overhaul costs are typically one-time expenditures that the company needs to pay to maintain an asset. Okay. And so the way you handle overhaul costs and economic life calculations, it depends on a couple things, right? So usually you know ahead of time, when an overhaul cost is going to take place, okay? So if you salvage or if you choose to replace an asset before an overhaul takes place, then you don't factor it into the EUAW, right? Right? So that makes sense, right? And so if you know this kind of big overhaul cost is coming, if you sell your asset kind of before that happens, then you don't have to pay for it. It doesn't factor into your yearly expenses. Okay. If you salvage it after the overhaul date, okay, and so we keep an asset after that overhaul is scheduled to occur, then of course then we pay it, then we factor into our calculations. Okay. But remember, we're converting everything to a uniform series. Okay. And so when you're converting kind of a single future sum into a uniform series, oftentimes you have to use a non-standard conversion. And so what that means is basically taking two conversion factors at once. Okay? And so since it happens pretty often, I have a formula here for you. Okay? So the EUAC of an overhaul is equal to F. Okay. So F represents the cost of the overhaul. First thing I would do is I would take this overhaul and convert it back to the present day, to year 0. So I would do P over F multiplied by I. And then the N that you plug in here, the N that you plug in is the time when the overhaul takes place. Okay. So we're taking an overhaul cost, we're converting it back to the present day. Then once we have it in the present day, we can do an A over P. Okay, so we're taking that present day sum and then converting it to a uniform series. And so this A over P, I multiplied by or applied at and current. Okay, where this and current, this is the current year or the current time that we are evaluating on economic life. Okay. One thing to know is that these two ends, okay, are often going to be different, right? Because the overhaul is set to occur at a fixed point in time, but we're doing our calculations for lots of different years. Okay, so these two are often different. So if you're doing economic life calculations with an overhaul cost, you really need to kind of pay attention to what you're plugging in for these ones here. Okay. All right, any questions before we jump into another example? Okay, so we have 5 more minutes, so I think I'll just have time to just write down the example, and then we'll actually do it next time. Okay, so for this example, let's say that we have an asset that had an initial cost of $18,000. Maintenance on this asset is gonna be $900 per year. But it's set to increase by $500 per year. Okay. The market value for the machine is going to be $5,000 if sold at the end of year one. Okay. So you have a huge drop off in value. You paid $18,000 for it, and then you use it for a year, and it's only worth $5,000 after that. Okay. But after that, the decline slows down quite a bit. So after year one, its market value will decrease by 10% per year. All right, there is an overhaul cost that's planned. And so if you're using the machine past the 6th year or at the 6th year, there's an overhaul cost of $3,240. And so if we use the machine beyond the 6th year, then we have to pay this. If we sell it before that 6th year, then we don't have to pay it. Okay. All right, the useful life of this machine is 10 years. And our interest rate here is 8%. Okay. And just like the first example, we're going to compute the economic life of this machine. All right, so that's all we got time for today. So, I guess you can think about it over the weekend, I guess, or you can read ahead in the notes. But when we come back on Tuesday, we'll continue. We'll pick up right where this example leaves off, and then we'll see how this is done. Okay. Any final questions on this before we wrap it up for today? Okay. All right. So if you haven't picked up your exam yet, I have the exams here up at the front. This will be the last day I'll bring them though. So if you don't pick them up today, then you can come to my office and pick it up after that. Okay. All right. So thank you guys for coming today. Hope you guys have a good weekend. Don't get blown away by the wind. Hopefully your allergies are doing better than mine too. And I will see you guys next week.
Wait, as bad.
Yeah,
I've been taking Zyrtec.
I should have taken something this morning. I kind of left the house in a hurry, but
Yeah.
maybe I should get something from the
They carry with me everywhere.
that's a good idea.
Are you
You too,
gonna-
Zaka.
But then I'm going.
Yeah, sometimes.
You're right.
Yeah.
Face. You wanna do this place and you-
I don't know. I guess go and look on that, or if I was doing that Sunday, and so. So that he's like, let's do, right, the whole.
Yeah. and then we're doing it for a year. So then people- No, I really like that. Okay. Extends everything.
Question.